Bismillahirrahmanirrahim. Dear students, this is the first year class, grade 11, and we are continuing the quantum numbers. Then I will discuss tell you about the shells and subshells, and also I told you about the introduction about the shells and subshells. So the last quantum number, we completed the three quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and little introduction about the spin quantum number. The last one is remain behind. That's called number 4. Is called spin quantum number. So, dear students, spin quantum number describes the spin of the electron, direction of an orbital. Describe the direction of spin of an orbital. So, in 1925, the Bornist suggested that electron while moving in an orbital around the nucleus also rotate or spins about its own axis. We call self-rotation about its own axis. It means that we call self-rotation. Self-rotation of electron. So 50% chances clockwise and anti-clockwise. 50% chances for the rotation of electron about its own axis. So we call clockwise and anti-clockwise. So written here, this is called a self-rotation electron, written also in your book. This spinning of electron is associated with the magnetic field, hence a magnetic movement. So this is about the fourth quantum number. So you can see in the diagram, the electron is going to be rotate clockwise, and others called anti-clockwise, plus half and minus half. So this is about only the self-rotation of electrons, and the electron is going to rotate opposite spins its own axis. So this quantum number is not derived from the Schrödinger wave equation. Only first three quantum numbers are derived by the wave equation. So students, this is the complete properties. These are the complete properties or complete address of the electron, starting from the orbit, circular orbit, to the sub-energy levels. Then these sub-energy levels are degenerated orbitals. Then how they are going to be rotated. So yesterday I told you you have to give the answer about it, that electron has a 50% clockwise chance and 50% anti-clockwise chances according to the scientists. So this is called a self-rotation of the electron. One is called plus half and another is called minus half. So we will write in this form like this one. This is a clockwise, this is anti-clockwise, and you can write also in this form. This is a paired. If you are going to write unpaired, one electron must be like this one. This is only one electron present in the SPD, with the two electron present like this or this one. So you can write this or this. But if you write one, so you should write in this form. So now, yesterday also I talked about the shapes of the orbitals, and S orbital is a spherical, round shape spherical, and the size of this orbital depends upon the quantum number, principal quantum number, value of n. So smaller the value of n, you can see the small size of the S orbital. Higher the value of n, 2, 3, you will see the big size, larger size for the S orbital. So it depends upon the value of principal quantum number. So this is the same definition which is given according to Bohr's atomic model, the circular path where electrons can revolve. A cloud showing the probability of finding electrons of the charged cloud around the nucleus. We are already done the atomic orbital. It's the same. There's no, I will not repeat this one. The circular path in which electrons revolve around the nucleus is called shell. We call it shell. And the path, the space around the nucleus where the probability of finding electron is the maximum 95% is called atomic orbital. So this is the S spherical, 1s, 2s, 3s. You can see I'm not going to explain again. The probability of finding electron is a 0 between the two orbitals. This plane is called a node or nodal plane. This is called a nodal plane or nodal surface. P orbitals, according to the magnetic quantum number Px, Py and Pz, the shapes are given here, and they depends upon the number of the size of the P shape, also depends upon principal quantum number. So these are called degenerated orbitals. If you see for the D, again D has 5 degenerated orbitals. You can see the shapes. You have to draw. You can see from the internet, very colorful these are given. You have to draw them very well. dxy, dyz, dxz, dx square minus y square, and dz square. 1, 2, 3, 4, 5, 6 about the axes. So you have to draw these, maybe come in examination. F orbitals, they have a 7 direction in the space placing in the magnetic field. They are highly complicated. That's why their structures are not given, but I told you can see from the internet. So this is about the shell and subshell. Now 2.8 example. This is the whole summary of the all quantum numbers. Describe the allow combinations of n, l, and m quantum numbers, where n is called principal quantum number, l is called azimuthal quantum number, and m is called a magnetic quantum number. So students, if you see this topic 2.8, if n is equal to 1, there is the n principal quantum number, l azimuthal quantum number, m magnetic quantum number. So when the n is equal to 4, K, L, M, N shell. This is the shell number n according to Bohr's atomic model. When n is equal to 4, so L has a value of 3, 2, 1, 0 or 0, 1, 2, 3, S, P, D and F. S, P, D and F. So when the n is equal to 4 and L is equal to 0, I told you yesterday that n will be 0, the S orbit. When the L is equal to 1, so they have a 3 degenerated orbital according to magnetic quantum number +1, 0 and -1. This is Px, Py and Pz. When L is equal to 2, so n will be -2, -1, 0, +1, +2. There are 5 degenerated orbitals, means all the d orbitals already are names, give the names. If the L is equal to 3, then -3, -2, -1, 0 plus 3 plus 2 plus 1. So there are 7 degenerated orbitals according to the magnetic quantum number. This is given for the N shell according to Bohr's atomic model, and how the principal quantum number, azimuthal quantum number and magnetic quantum number are explained. This is example. Now students, you've done the electronic configuration. In grade 9, one electronic configuration is in grade 9 electronic configuration, two types. One is according to Bohr's atomic model. Bohr's atomic model means 2n square. We already discussed in the previous lecture. 2n square. According to Bohr model. Then there is modern electronic configuration according to the wave nature, and we involve sub-energy levels S, P, D and F. So electron representation of filling of electrons in different orbitals S, P, D, F of an atom is called electronic configuration, arrangement of the electrons. How we arrange, how we represent the electrons in different sub-energy levels. So just I want to explain, then I will explain this one. There is a defect in Bohr model. There is a defect in Bohr model. Just I am writing here what's the defect. You have a K shell. No, this is a potassium. Atomic number is 19. Potassium atomic number is 19 and atomic mass is 39. So according to Bohr's model, if I am going to write protons, atomic number and number of protons same, you've done the Moseley's theory. So protons are 19 and 39 minus 19, so neutrons are 20. This is the nucleus. According to distribution, K shell has 2 electrons according to 2n square. Then there is a L shell. So L shell has 8 electrons. This is the L shell. So there are 8 electrons. Total should be 19. There is a mistake here. According to 2n square, when I am going to draw M shell, so students, M shell occupy 18 electrons. M shell has ability to accommodate 18 electrons, and if you are going to see 2 are in K shell, 8 are in the L shell, 10 remaining there are 9. So there 9 must enter in the M shell. These all 9 electrons must be present in the M shell because it has ability to accommodate total 18. But no. You should accommodate next 8 electrons in the M shell. M shell again 8 electrons and one will be in the N shell. So K 2 L 8 M 8 and 1. Students, this is the electronic configuration of the potassium according to Bohr's atomic model with its defect. Now it is correct. Why this one? You done in the grade 9. I am going to repeat. There are two reasons are here. According to the Lewis concept, Professor J.M. Lewis, there are two rules we apply for the accommodation of electrons. Some elements, they are going to complete their valence shell by 2 electrons we call duplet rule. And majority of other elements, they complete their valence shell by 8 electrons we call octet rule. Octet. So if you consider this one, and also if you see the periodic table, in the periodic table potassium is present in the group 1A, alkali metal. The group 1A represents that in the valence shell there must be 1 electron. If I put 9, then it should be present in the group number 9. There should be 9 electrons in its valence shell. But this is wrong. And other argue is that potassium it is a monovalent. It has a positive 1 charge. So if there are 9, so it means that it should lose all 9 electrons to get positive 9 oxidation number? No. Its oxidation number is +1. It loses 1 electron only. It is present in the group number 1A alkali metal. So next this orbit, which is M, must be completed by the 8 octet rule. So when it loses this electron to give a positive 1 cation potassium, so the last shell will be completed by the 8 electrons. So two rules are applied, duplet rule and octet rule. So this is somehow explanation about the, there are many other, calcium also, iron, many you will find there are discrepancies if you are going to fill this one, K shell, L shell, M shell. So that is why the modern electronic configuration is introduced. Modern electronic configuration. So I am going to omit, you done in grade 9 this one. Now in the modern electronic configuration, we involve S, P, D and F sub-energy levels. S, P, D and sub-energy levels we are going to involve this one. So students, I am going to draw here. This is the N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5, N is equal to 6, N is equal to 7. There is one thing, mostly we write up to 7. We write up to 7. You done in these spectral series, mostly I use 7 up. The reason because of in the periodic table there are 7 periods. There are 7 periods, but still the elements which were discovered either in the natural way or in the artificial way. So only the 7 periods involved. That's why we use up to 7, but this world is now going to be modernized day by day. Maybe other elements discovered and maybe the 8th period is going to be introduced, but still not. Okay. So we use these SPDF according to these number of shells. Number of shells. So there are 3 principles to explain the modern electronic configuration. 3 principles. Number 1, Aufbau principle. I will explain. Aufbau principle, Pauli's exclusion principle, and Hund's rule. 3. So according to the Aufbau principle, when you are going to accommodate electrons, so you have to start the energy level or orbital having the lowest energy. Lowest energy. You have to fill first orbital which has the lowest energy, then higher, then higher, then higher, and we call state of the stairs. So S has the lowest energy, less than P, P is less than D, and D is less than F. This is the sequence of increasing energy. Then I will explain about this one. So this is the number of period 1, 2, 3, 4, 5, 6, or we can say value of N. Then you are seeing that according to the value of L, S0, 1, 2, 3, 0, 1, 2, 3. So L is equal to 0. When L is equal to 0, so this is the 1, so we write 1S. 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 Then 2S. 3S. 4S. 5S. 6S. 7S. When L is equal to 0, S. So when L is equal to 1, when L is equal to 1, you find that 2, P starts from 2, P does not start from 1. So that is why there will be a 2P, 3P, 4P, 5P, 6P, and 7P. Like this one. Then L is equal to 2. So D starts from 3. So that's why 3D, 4D, 5D, 6D, and 7D. Like this one. And when L is equal to 3, when L is equal to 3, we have an F. 0, 1, 2, 3. So F starts from 4. 4, F, 5, F, 6, F, 7, F. Now, I am telling you, when you are going to fill the orbitals according to Aufbau principle, increasing the energy, the formula we use N plus N. This is a formula. This explains the energy of the orbital. I will explain. N plus L. N is a principal quantum number. This 1, 2, 3, 4, 5, 6, 7. And L value is 0 as this like this one. So we have to complete. Now students, when you are going to start filling, this S has the lowest energy. S has the lowest energy, so you must start electronic configuration from the 1s. So this will be 1s you have to fill first. Lowest energy, I will use this formula also. Then you have to start 1s, then 2s. This one. Then 2s. Okay. Now students, then you have a 2s, this one, according to n plus l rule. Then 2p and 3s. 2p, 3s. Then 3p, 4s. 3p, 4s. Then 3d, 4p and 5s. Like this. Then 4d, 5p, 6s. Like this one. You can write. You can write like this. This one. This one. Yes, like this. This is so on and so forth. According to write this one. Now students, there is some questions. There are questions. If you see the Bohr's atomic model, K shell, this is okay, correct. This is a K shell 1 and is equal to 1. This is correct, okay. This is the 2, again L shell. This is the L shell. This is the M shell. This is the M shell. But if you read here, 4s, 4 is a K, L, and M. This is the shell M. And this is the shell M. Alphabetically, M is first, then N. But when you are going to arrange the electrons according to modern electronic configuration by using Aufbau principle, so you have to first fill 4s, then you have to fill 3d. Because this is the formula, you have to calculate the energy according to Aufbau's principle. So dear students, I am going to calculate this. I am using this. So I am going to remove this ambiguity. So 4s. Apply this formula. N means 4. Okay, this N means 4 plus the value of L, S value is 0. So you have the answer 4. So energy of 4s is only 4 because S 0. The energy of 4s is a 4 because 4 plus 0 is equal to 4. Now if you see for the 3d, so this is a 3 and the value of d is also 2. This d value is 2. So 2 plus 3, 5. So the energy of 3d is 5. Energy of d, see this one. D is here. Value of this 2. So this 3 plus 2, 5. So 5 is greater than 4. 5 is greater than 4. So according to Aufbau principle, when we are going to move from one step to second step, third step, so first should be this, then this. But according to Bohr's model, 3D should come here and 4s should come here. But according to modern electronic configuration, according to the Aufbau's principle, you must use this formula and follow this. There's one point, then I stop. If you see the 2p and 3s, 2p, 3s, okay. 2, p is 1 is equal to 3. 3s, 3 plus 1, sorry 0, s is 0, so you will get 3 again. Now when I am going to explain 2p and 3s, so using this formula, so students, you are getting same answer. The energy is the same for this. So when energy is the same, then why 2p is before and 3s is after? Because energy is same. Then according to the Aufbau principle and other scientists research, they say that when the energy is equal, then you have to see